welcome back, Patriots. I am Mr. Love, aka the Math Patriot, bringing you another fun and exciting lesson in the wide world of high school geometry. And I've got some students looking at me like I'm crazy right now. I got new students from another class transfer in, and this is their first day experience recording. So, anyway, yes, I pretend to be a YouTuber in class during 4B. All right, so let's go ahead and move on. This is our last lesson in the parallel lines and transversals unit. So next class period we'll be having a test review and then test thereafter, which I believe for us will be on Wednesday of next week. If you're watching this on YouTube, I really hope you don't think you have a test on Wednesday. All right. So this entire, I can't believe I just lost what I was going to say. I haven't done this in a while. I'm going to go edit this part of the video out. Why? It's like a dead 30 seconds. Okay. Now, this entire unit, we've started off with our transversals of assuming that our lines were parallel from the beginning. And we said if the lines are parallel and they're cut by a transversal, then we know that these two angles are congruent. How do I know that? The alternate exterior angles theorem. Okay, alternate exterior angles theorem. All right, what do I call these two? Consecutive, no. Corresponding angles, and those are congruent. What about these guys right here? Consecutive interior angles, and those guys are supplementary. Okay, so we're actually going to go the other direction now. Okay, we're going to start off with the idea of what if I don't know that these two lines are parallel? Is it possible for me to prove that they're parallel? In order to do that, we've got to revisit one of our friends from chapter 2. No, we're not bottle flipping right now. Oh, throw it away. Okay. Just throw it away then. Oh, there's no water in it. You're not bottle flipping. Okay. All right, so let's talk about our converses from Unit 2. What was a converse? It's not a shoe. We take the hypothesis and the conclusion and we switch them. So this thing goes there, and this thing goes there, right? So if a bear is a polar bear, then it is white. Okay, there's our converse. Now, could be right, could be wrong, but it's just the fact of converse means you switch the hypothesis and conclusion. So, let's look at the converse of our corresponding angles postulate. Notice how this one starts out. It says, if two lines are cut by a transversal, it does not give any sort of assumption about those two lines, just that I have two lines cut by a transversal. Also, I'm assuming the corresponding angles are congruent. So that would mean I look at it, and I've got A and B cut by transversal. It's unlabeled here. Let's just call it L. And 1 and 3 are congruent angles. That is sufficient evidence for me to prove that the lines A and B are parallel. Excuse me. A is parallel to B. Now I really need to go do some editing. Get that sneeze out of there. Okay. So that gives me enough evidence to prove that A is parallel to B. We would call that the corresponding angle postulate converse. Okay? So I can use that in a proof as justification for two lines being parallel. Okay? We've also got, yes ma'am. Thank you, thank you. All right, Andrea, you're leaving. And by the way, they were not clapping because she's leaving. They're clapping because that's just what we do anytime somebody walks in the classroom. Okay. Riley, be nice. All right, so we've also got our alternate exterior angles converse, which says if I have two lines cut by a transversal, and I know that alternate exterior angles are congruent, therefore, lines are parallel. Okay? So, I'm not going to spend a lot of time on every single one of these. We've got a version for all of them. Consecutive interior angles. If they are supplementary, then the lines are parallel. If alternate interior angles are congruent, then they're parallel. Also, our weird one here, the perpendicular transversal converse. if two lines are perpendicular to the same line in the parallel, that's essentially just a special case of take any one of those, because if two lines are perpendicular, then their corresponding angles will be congruent. Their alternate exterior angles will be congruent. Their alternate interiors will be congruent. Their consecutive interiors will be supplementary. It's just a special case of it, okay? So, two lines are perpendicular, then, or to the same line, then those two lines are parallel. All right, there's the shortcut on it. Yeah, same thing we've been saying just over and over again. Not really difficult stuff here, okay? Just proving that the converses are all allowed. So let's go ahead and go through and see a few examples here. If angle 1 is congruent to angle 3, so angle 1 is congruent to angle 3, is it possible that any of my lines here are parallel to each other? Which ones? Okay, we know A is parallel to B. And the reasoning for that, well, what's the relationship between 1 and 3? So I would call that the corresponding angle postulate converse. Okay? Questions? Notice I know nothing about line C. Okay, I have no information about it. Well, I'm calling it the converse because I'm going the reverse direction. The corresponding angles postulate says that if you have parallel lines cut by transversal, then corresponding angles are congruent. Now I got the opposite direction. Corresponding angles are congruent proves that. Okay? Go ahead. Ooh, I should build a noise profile and see if I can cut out the pencil sharpener. Ooh. All right. You know what? I'll try that later. All right. Yeah, I think that if we cut all that extra noise out, it would just like cut everything out. But we can try. Okay, example 2. We've got 103 degrees for angle 1, 100 degrees for angle 4, and is it possible to prove that any of the lines are parallel? First off, B. We know nothing about angle B, or line B, right? Okay, so what's the relationship between the angle 1 and angle 4? What's their named relationship? Alternate interiors. Now, in order for the lines to be parallel, alternate interiors would have to be congruent. Are they congruent? No. So, no. Not possible. Now, again, notice I guess it is in theory possible for line B to be parallel to A or C, but I don't have enough evidence to prove that. So all I know is that A and C are not parallel. All right, 3. Ma'am. Well, I can go straight from 1 to 4. The question was, do I need to go from 1 to 3 and then 3 to 4? No, because 1 and 4 are alternate interior angles. And since I can see 103 is not equal to 100, that's sufficient. That's all I need to show they're not parallel. All right, 5. Sorry, example 3. Angle 1 is congruent to angle 5. What's congruent? L is congruent. I'm sorry. What's parallel? L is parallel to what? N. Why? Corresponding angles. Converse. All right. Honestly, that was a mistake. I meant to do 1 and 6. So I got alternate exterior angles. As it is, our example said two corresponding angles, but at this point, you're getting the idea. That's what matters. Okay, angle 4 is 105 degrees. Angle 5 is 70 degrees. All right, what's our named relationship between 4 and 5? Okay, so the name is consecutive interiors. In order for M to be parallel to N, what would have to be true about those consecutive interiors? All right, that's be supplementary, equal 180. In this case, they are 175. Therefore, those are not parallel. So that's not possible. Not possible. No dice. No possible. I really don't know the origin of the no dice phrase. I don't know. All right, so notice on number 5. 5 gives us a slightly different set of directions than what we've seen before. earlier it would say, given that m is parallel to n, what is the value of x? Now in this case it says, find the measure of ABC to force m to be parallel to n. Now in order to force it to be parallel, m to be parallel to n, these two would have to be congruent because they're alternate interior angles. So in order to do that, we have to find x and force them to be equal basically. So we got 3x plus 10 is equal to 6x minus 20. Subtract 3x from both sides gives me 3x on the right. Add 20 to both sides gives me 30 on the left. Yeah, which means x equals 10. All right, now, my favorite question to ever ask in any of my geometry classes. Am I done? How do you know? Right, I want the angle measure, not the variable value. So, measure of angle ABC is equal to, well, let's go ahead and plug it in. 6 times 10 minus 20. So 6 times 10 is 60 minus 20 is 40 degrees. Now am I done? Yeah, I boxed it, so I got to be done. But I didn't do done, dude. Sorry. So, ask your measure of angle ABC, so we're good. Wait, you actually found a measure of what? Well, yeah, if you found DAB, it's the same as ABC. Easiest ABC. 1, 2, 3. All right. I know, I'm sorry. Okay, similar idea, but this time with alternate exterior angles. Find the value of the measure of the angle to force those two to be parallel. So, what am I going to do? Do the thingy. Find the x to do what? Right, but what equation am I using to find x? The alternate exterior angles are congruent. So 11x minus 25 equals 7x plus 35. All right, now what? Subtract 7 on both sides gives me 4x. Add 25 on both sides gives me 60. Divide by 4 and I get x equals 15. Am I done? No. So, measure of angle ZYN is my bottom angle here. So 7 times 15 plus 35. Well, 7 times 15 to 105 plus 35. Measure of angle ZYN equals 140. Now I'm done. Questions? No? All right. Hey, we're plowing through these fast today. All right, find x so that GH is parallel to RS. All right, alternate interiors need to be congruent. All right, so we got 9x. 9x minus 21 equals 7x minus 3. So, subtract 7x and I get 2x, add 21, you get 18. Therefore, x equals 9. All right, am I done? Yes. Trick question. Yes, find x. I'm done. Woohoo! I know. How dare I ask you to just find x? This is geometry, not algebra. Just find x. Okay. Now, all of your favorite things. Proofs. They incorporate if-then statements. Okay. So let's go ahead and mark what we're given here. Angle 1 is congruent. Oh, let me do it in a different color. Angle 1 is congruent to angle 2. Statement number 1. How do I know that? Given. All right. Angle 1 is congruent to angle 3. How do I know that? That was easy. All right. And now I need to prove that AB is parallel to DC. Now, in order to do that, I need one of my special categories to line up as being either congruent or supplementary. So, looking at AB and DC, do I have one of my special sets labeled here? Yeah, what do you got? Oh, okay. So I don't like the way you said that. You said angle 2 is congruent to 3 because of the alternate interior angles theorem. The alternate interior angles theorem starts with things being parallel. I am not given this is parallel, so I can't use that to show that 2 is congruent to 3. Right, because I'm using the converse to get 2 parallel. All right, what do you got, Daniel?
AB is parallel to DC because 2 is congruent to 3 because of the transitive property.
Okay, so we need to go to the transitive property first. So angle 2 is congruent to angle 3 by transitive. And that is using 1 and 2. And then now that I have that angle 2 is congruent to angle 3, now I can come in and say that segment AB is parallel to, let's stop with the pins over there, parallel to DC. And that is because of the alternate interior angles converse. Done. Mic drop. New students, we'll talk about QED in a second after we cut the recording. All right, any questions on that proof? All right, that one's pretty straightforward. This one's a little bit more involved because, number one, we've got 2 things we got to prove. L is parallel to M, and R is parallel to S. So let's get in here what we have. 1 is congruent to 5, and 14 is supplementary to 5. I'm just going to put my dots there so I can know what I've got. Let's get my my first given in there. 1 is congruent to 5. And that is given. Okay, so let's first just talk about 1 and 5. Is that one of my special pairs? Okay, it's what kind of pair? Corresponding angles for which 2 lines, though? Yeah, the corresponding angles for L and M. So, on L and M, I've got the corresponding angles are congruent. I can go ahead and use the corresponding angle postulate converse to show that those 2 are parallel. So, I can say that L is parallel to M, and that is by the corresponding angle postulate converse. Okay, so I've got this one done already. Yes. Okay. Now, I've got to somehow show that R is parallel to S. Now, there's multiple ways of doing this. All right, I'm going to choose one just to force one of the converses we haven't used yet. And I know you can probably come up with other ways. So here's what I'm going to do. I'm going to say that 14 and 15 are a linear pair. So angle 14 and angle 15 are a linear pair. How do I know that? That's the definition of a linear pair. Now, I also know that angle 14 is supplementary to angle 15. Anybody remember what I do that? What tells me that? Linear pairs are supplementary? Supplement theorem? All right. Now, I'm going to go ahead and jump in and do my other given. Right, because they're a linear pair. So linear pairs are supplementary. All right, now I also know that angle 14 is supplementary to angle 5. Oh, this should have been a 4 here. And then I can use my 5 there. How do I know that 14 is supplementary to 5? Okay, that's my given. And now, because I know that 14 is supplementary to 5 and 14 is supplementary to 15, do you remember what that one is? Not transitive. It's the congruent supplement theorem. The congruent supplement theorem says that if two angles are supplementary to the same angle, then they are congruent. So we got the congruent supplement theorem. That tells me that angle 5 is congruent to angle 15. And now that I knew that angle 5 is congruent to angle 15, are 5 and 15 one of my special pairs?
Yes.
Yes. What kind of pair are they?
Alternate exterior angles.
All right, and alternate exterior. Oh, stop that. Alternate exterior angles are congruent. Tells me that R is parallel to S. That's the alternate exterior angles theorem. Converse. And it looks like I wanted to show L is parallel to M, which I did in step 2. R is parallel to S, which I did in step 7. Therefore, I am done. And let's make that actually look nice. QED. And that's it. All right, so that's it for our lesson. And as always, please stay patriotic.